Hello everybody, welcome back to now we'll come to our second part of our video where we talk about the common lab apparatus. So common lab apparatus. Now what are these apparatus used for? So lab apparatus are instruments that we can find in the lab, in a science lab, in order to help us to measure and to collect the data. So one example is the filter funnel where it is used to actually separate the insoluble solid from then liquid solution. So to separate an insoluble. Now what do we mean by insoluble? Insoluble is basically an item that cannot be uh, dissolved in the solvent that you use. So that is an example of insoluble. So when we look at insoluble, let's say stones, pebbles, when you throw it in water, we say that the pebble is actually insoluble in the water as you don't see the pebble actually being dissolved in the water. However, if you say salt, you throw it into water, okay, or Milo powder, you put it into water, the powders will actually dissolve, and that's where we say that such solid particles they're actually soluble in the water used. So in this case, what happens is through using the filter funnel, you would see that of course there's another instrument here that you will be able to add in the later that we'll discuss more in the separate in another chapter. It's the filter paper. So when you add in the solution, only the solid particles will reside within the top of the filter paper, and this one we actually call this as the residue. That means what is actually remaining, and whatever drips out after that, these are known as the filtrates. Okay, so in this case, it's the filter funnel helps us to separate an insoluble solid from a liquid solution or a liquid. Okay, next we look at the flat bottom flask. Now, the flat bottom flask and the round bottom flask, they're actually more or less the same. The only difference is that one is actually flat at the bottom and the other is more round. Now, what is it usually used for? It's used to contain your chemicals. And most of the time, these are apparatus used when you are doing your experiment to prepare it. Okay, so the flat bottom flask is mainly for preparation. Actually, both is also to use for collection or to contain your chemicals. But one distinct difference between the both of them is that for the flat bottom flask, you don't heat. No heating is required. On the other hand, for the round bottom flask, heating can be done, or usually heating is required. So these are just two main things, and of course the flat bottom flask allows you to just put it on the table. It won't bounce around. Next, we look at the test tube and the boiling tube. Now, these two, it also helps to contain your substance. Now, but do take note, for the substance, for the test tube, right, it can be heated. Whereas for boiling tube, is to also contain substances, but in larger amount. Okay, and of course the boiling tube, right, because of the name boiling, it can actually take a higher heat temperature as compared to the test tube. Okay, but of course the ones that you use in the science labs are good quality. You can actually do direct heating. Nothing will actually it won't break or shatter in pieces. So generally, it's test tube is used mainly to just contain small amount of substances. But if you are putting in solid things like in bio, you do food tests, which actually you cut and things like this. You would then want to use a boiling tube, or you want to put leaf inside. Then a boiling tube will be more or less more recommendable. Next, beaker is also used to help to contain or to collect liquid solution. So it helps to collect / contain liquid solutions as compared to your measuring cylinder. So for the beaker, right, and for the measuring cylinder, it's just that the measuring cylinder, you're able to adjust to collect the same volume, but when you read the volume, right, you can read it with smaller division, which means you can go up to understand 1 cm3 for a 100 ml beaker. But so this is the smallest unit that you can go. But for a beaker, you are looking at maybe 50 cm cube. So it will jump from 0 to 50 cm cube. Then from 50, you go to 100 cm cube. then 150, and so on and so forth. Whereas for measuring cylinder, it will be like 1, 2, 3, 4, 5. Some would actually go to 1.5, 2, 2.5, 3. So depending on which instrument you use, for greater precision measurement of the volume of the substance, I would use the measuring cylinder. Okay, then we look at pipette. Now for pipette is to mainly measure fixed volume of solution or the liquid. Okay, so this one is the ones that you use in your labs are mainly 25.0 cm cube. Do take note that it is to 1 decimal place, but this doesn't mean that it will measure 25.1, 25.2. No, instead, this measure the pipette is so unique that it's only able to measure fixed volume of solution. So the key accurate answer is the keyword is actually fixed, and they are able to measure it accurately. On the other hand, when we look at the burette, right, for the burette, it doesn't measure fixed volume. Instead, it is able to measure smaller volume, or I wouldn't say smaller volume. It is able to measure volumes to an accuracy of 0.1 cm cube. That means that for the measuring cylinder, it's in division of 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, etc. This one is maybe 50, 100, 150 cm cube, etc. This one, pipette is only fixed. Burette, on the other hand, is like 1.1, 1.2, 1.3, 1.4, so on and so forth. Okay. So this is also the burette, but of course when you go to Sec 3, you'll realize that there is a more precision measurement for burette to a 0.05. Okay, but do take note that of all the instrument, the most accurate to measure volume is actually the burette. So in MCQ, if they were to ever ask, because I usually do see this in MCQ, the burette measures is the most accurate instrument that you want to use to measure volume, but of course not say 10,000 milliliter or 10,000 cm cube. It usually ranges until somewhere between 50 cm cube or so. On the other hand, for pipette, is to measure fixed volume. Beaker and measuring cylinder is the more larger is to take up larger amount of volume of solution. And next we look at what are some of the safety or common hazard warning symbol. Now, each of these warning symbol can come out under a structured question at the first few months of your smaller test, or it can be an MCQ. So these are the 6 main ones. There are actually more, but these are the 6 main ones that you usually see. We have flammable, is basically one flame there, and basically this is telling you that substance are able to burn very easily. Then of course, if you have the more nicer radioactive, oops, actually it's the other way, the color. Okay, so radioactive substance is the one that can emit radiation, and this is actually one of the more dangerous one because you can't really see. So it's like it's just like you can't see virus, right? Like let's say someone like a coronavirus coming to you, you can like try to run away if you can see it, but this one you can't. So I mean coronavirus you also can't, but for this particular one, some chemicals are able to emit radiations, and you wouldn't want to be near them. So the container would also be very special. It's most probably made of lead to prevent leakage of such radiation. So there were cases where nuclear plants exploded and this released radiation. Now such radiation, right, they do not die off very fast. What is fast? A few minutes or hours or days. The radiation can actually be up there for a few years or so. So this is one of the main danger. Corrosive substance. Corrosive is mainly the one that is any substances that would be able to burn your skin or eye upon contact. So this is something that to take note, and what you can see is that usually there'll be some form of indent or like a sudden drop being absorbed by the chemical. So this is corrosiveness. You will usually see this for acid bottles. Irritable are basically substance that can irritate your eyes, not burn. Irritate meaning it can be itchy, you can see some red patches and things like this. And of course, if any of this were to happen in the science lab, please inform your teacher straight away. Don't play around with chemicals. It is not that safe. Then, of course, toxic or poisonous is basically like a pirate ship. You see a skull, and you know when you see something like that, it's most probably instantaneous death. Okay, so it can cause death or harm your body if ever swallowed, inhaled, or even to be absorbed through the skin. So never play with poisonous things, toxic. I don't think in the science lab you will be able to see things like this. But please, if you ever see something like this is something that you have to listen to your teacher's very clear instructions. You don't play with it. Next, we look at explosives. So explosives are basically substances, right, which can explode easily when heated or mixed with other substances. So for example, you know your petrol bomb? You see something like this. So while in science lab we do use alcohols which are generally flammable or petrol which are flammable, explosiveness is really an instantaneous fire and it's and you will really hear a sound. Whereas for flammability is like the fire will just be there. Okay, like a candle, the fire. That's about all. Explosiveness is really it's really how to say instantaneous and it can cause a lot of danger to you. So these are the general ones to take note of. Do remember the symbol you might be asked to actually name. So for the naming wise, it's this one. So if you are given the pictures, these are the names. I don't think they will ask you to explain what it meant, but you might be required to give examples. So like for example, for flammability, we can talk about alcohol as one example. For radioactive, you can say uranium. For irritability, you can say things like ammonia, chloroform. Then of course, for corrosiveness, it can be acid or you can use hydrochloric acid. It's a very common acid found in the lab. Nitric acid. Then things that could be poisonous are like a mercury. So mercury are those that is found in your thermometer. So please don't go and play around with it. Or you can say even lead, cyanides. These are some examples. And then explosiveness are some of the metals like potassium, which these are what we call the reactive metals. And this one, right, they are so reactive that they can even react with water, cold water. So do listen to your teacher's instruction. You will learn more of this in Sec 3 or maybe in the next few lessons. Yep. Okay, if not, I will stop here for this portion. The next video, we will be watching how to use a Bunsen burner, and then it will be the end of this particular chapter. Please revise the work. We have already gone through the warning symbols. We also have went through what are some of the common apparatus, when to use it, when to choose to use it. So in exam, a structured question, they can say like, how do you measure 25.0 cm cube of water? Then the first thing is, 25.0. The number of 25.0 means you use pipette. Okay, the other one is 15 cm cube. 21, I believe there is also for 20. So these are something. Then if I want to measure 100 ml of water, I'll use beaker. If I want to measure 97 cm cube of water, I'll use measuring cylinder. If I want to measure 10.3 cm cube, I'll use the pipette. Okay, then so this is so you must be able to name these instruments as well and identify it. So this is a common kind of question if you are doing the normal ACAD syllabus. And then that's about all. Okay, then I'll see you in our next video. Do remember to like, subscribe, and click the notification bell for future videos. Thank you.